So you could ask the question, well, in that case, are there objects that are so distant that the light travelling from them began its journey close to the Big Bang itself? Is that possible? And the answer is yes. And that light was first detected in the 1960s. It's called the cosmic microwave background radiation. So essentially the idea is, how far can I look in every direction? You can look about 13.8 billion years into the past, back to the origin of the universe. That is the furthest we can see. We can't see further back than that because in earlier times the universe was so hot and so dense that it was in the form of what's known as a plasma. So essentially the atoms couldn't form. Temperature was too high for atoms to form. So you have electrons and primarily electrically charged protons and helium nuclei buzzing around in a thick soup, opaque to light. But at that moment, and it almost is a moment, cosmologically speaking, 380,000 years after the Big Bang, the universe is expanding and cooling, and it becomes cool enough for atoms to form, and becomes transparent almost in a moment. And so the light can journey across the universe ever since from that point, and we can detect it today. And that's what we call the cosmic microwave background. Here is the most recent photograph of that. So this is presented as a sphere because that's essentially what it is. It's a celestial sphere. So it's as far as you can look in every direction surrounding the Earth. And what you're looking at there is an almost featureless and formless universe. The colours correspond to slightly different temperatures in the light, which are really telling you that there are regions which are very slightly denser than other regions in the early universe, but it's almost uniform to 1 part in 100,000. So we're seeing an almost uniform soup, no stars, no galaxies, no large structures in the universe at all, and that is telling us that the universe has not always been the same as it is today. It is not eternal in the sense that it's not always been around with galaxies and stars and planets. At this point in the past, which we can see in the photograph, there were no stars and no planets and no galaxies. The universe was a hot, dense plasma. And that is essentially the clinching piece of evidence, certainly when it was first seen in the 1960s, that told us that this theoretical prediction that the universe was once very hot and very dense was correct. It matches observation. The universe was hot and dense 13.8 billion years ago. Now, those fluctuations, the different colours, as I said, correspond to very slightly different densities in the early universe. What do they tell us? These are the seeds of the galaxies.